Okay, in this video, this is 8.2 study guide, but this really goes with our 7.2 section with revealed geometry, and we're going to talk about parallelograms. So a parallelogram is a special kind of quadrilateral. Quadrilateral has 4 sides. Let me sketch a parallelogram here. So opposite sides of a parallelogram are congruent. And opposite angles of a parallelogram are congruent. And opposite sides of a parallelogram are parallel. So we have opposite sides, both parallel and congruent. So opposite sides both parallel and congruent. Now, one other thing about parallelograms, we do this in orange. The diagonals of a parallelogram go between the opposite vertices, and the diagonals of a parallelogram bisect each other. So those two pieces are congruent, and those two pieces are congruent, which means that this point in the middle is actually the midpoint. It's the midpoint of this segment, and it's the midpoint of this other segment. It's halfway in between. Each one of these pieces is congruent to each other. So this sets up algebra that we can do with these. Another thing we can do with algebra is opposite sides need to be congruent. So it might be algebra you set equal to each other because opposite sides. Opposite angles need to be congruent. Maybe algebra dealing with opposite angles or this way. And maybe length of diagonal versus piece of diagonal. Find out what the missing one is. Things like that. So let's look at what they have here for our list. So the following theorems all concern parallelograms. Opposite sides of a parallelogram are congruent. Opposite angles of a parallelogram are congruent. Consecutive angles, like if I call this P, A, R, L, consecutive angles, P and A, are going to be supplementary because this PL side and this AR side are both parallel to each other. So if we look at the PA side, that is a transversal between two parallel lines. So it sort of looks like this. And those angles, this angle LPA and this angle RAP, are same side interior angles, which means these guys need to be supplementary to each other. So consecutive angles are supplementary. Same thing works with AR, same pattern with AR. Parallel lines cut by transversal, same side interior angles are supplementary. So that's where the consecutive angles supplementary comes from. And then the diagonals of a parallelogram, which go between opposite vertices or angles, for the diagonals. So you've got like P, you skip A, and you have R. So they're alternate vertices as you move around a quadrilateral. That gives you the vertices that go with the diagonals. And the diagonals bisect each other. Okay. So that kind of sums up that part about parallelograms. Let's look at this example. So let's see what they're doing here. Well, just looking at this, let's solve this parallelogram. That's basically what they're going to do over here. So opposite sides of a parallelogram are congruent to each other. So if 8 is on that side, Z must be equal to 8. Opposite angles of a parallelogram are congruent. So if this one's at 72, the opposite angle, or X, has to be 72. And let's see what else we have. Same side interior angles are supplementary because this side and this side over here is they're parallel to each other. They don't look parallel, but I have them marked parallel, and these would be same side interior angles. So that means they're supplementary. So 180 take away 72 gives us 108 for the measure there at y. Okay, let's move up. Okay, now 1, 2, and 3. If each quadrilateral is a parallelogram, so we're assuming that these are parallelograms, and then we need to find these different values of x, y, and z. So I always like to maybe start with vertical angles. Let me zoom in on this a little bit. I have to remember to zoom back out. So if this is a 78 by vertical angles, a 78 is also going to be there. Probably didn't need to do that, but now I can see that these two are a linear pair, so I do 180 take away 78, I get 102. So z equals 102 degrees. Got that part. Let's see, what else can we do here? This is a 29 degree angle there. So if this is a 29, and if this is a parallelogram, I'm going to mark these two as the parallel sides here, and then in yellow I'm going to draw a Z. So there's the one of the parallel sides, here's the other parallel side, and here's the crossbar that connects the Z. These angles are alternate interior angles, which with parallel lines, alternate interior angles are congruent. So if I can find out what y is, well, if I can find out what this angle here is, I can find out, I don't know what y is. And this, by triangle sums, these angles all have to add to 180 degrees. So 78 and 29 comes out to be 107. If I take 180 minus 107, I get 73 degrees. So this angle is 73 degrees. Now by alternate interior angles, y is going to be 73 degrees. So that just leaves x. In this triangle up here, we also have triangle sums. These three have to be 180 degrees. So we have a 78 and a 78 and a 73. We have a 78 and a 73. That comes out to be 151 degrees, no, 151 degrees. If we subtract 151 from 180, we get 29 degrees. So x equals 29 degrees. And we've pretty much solved that diagram. Okay, let's look at number 2. So over here in number 2, switch colors up. See what we got. Okay, assuming this is a parallelogram, if I want to take care of this 44 here. So if I kind of think about the Z going this way, I've got that, and this goes up here like this, that's the transversal, and then we have the other parallel side. So these two sides are parallel because it's a parallelogram. This pattern gives me alternate interior angles. So these two angles are congruent to each other. That means y must be 44 degrees. And throw 44 in there. Now, in a parallelogram, opposite angles are congruent. So this angle and this angle have to be congruent to each other. Let me do two arcs there. And these two together make up this red marked angle, and we have a 44 and a 31. That gives me 75 degrees. So if this is 75 degrees, this angle down here also has to be 75 degrees because it's an opposite angle. So I have 75 equals 44 plus x. These two added together have to make the 75, same as the opposite side. Take away 44 from both sides, and we get 31 degrees. So x equals 31. Check that out. So yeah, that adds up to 75. So x is 31. So that leaves us with z to look for. Opposite angles are congruent. Another way to do this would be to add these two up, subtract from 180, and get C using triangle sums. But the obvious shortest cut way is to use one of the properties of a parallelogram, which is that opposite angles are congruent. So if this angle up here is 105, this angle down here is congruent to it. Z also has to be 105. And that's it for that one. So let me zoom down a little bit here. Okay, let's look at number 3. Number 3, let's see. Well, first off, opposite angles congruent. X is going to be 70. X is going to be 73. We bring this in one more notch down. So X is going to be 73. And here we have the same side interior angles. Again, if this side and this side are parallel to each other, if I kind of draw the parallel line through here, now this line here, this side here becomes a transversal. These angles are going to be supplementary. So 108 take away 73, or 180 take away 73 comes out to be 107. So Z is 107 degrees. And we can check here, 107 and 73, we could have done it this way. That makes 180 that way. Going this way, this also has to be 180. Or if this is 107, opposite angle, this has to be 107. Now, supplementary to this, and we could check it out, like going 180 this way, 180 this way, 180 this way, 180 this way. They're all same side interior angles, depending on which parallel lines you're using. These two angles here, though, are a linear pair. So if I do 180 take away 107, I come out with 73 degrees. So Y equals 73 degrees also. And we've solved that diagram. Let's look at number 4. So number 4, they're talking about a parallelogram, ABCD. So they're not giving us a diagram to refer to, so we should always automatically think about sketching a diagram. So I'm going to sketch a parallelogram, and I'm going to name it ABCD. These are supposed to be parallel. When you sketch the diagram, you just go with what it's supposed to be. It doesn't have to be to scale, but you're kind of using it as a graphic organizer. So we got this parallelogram. It says measure of angle A is 3x. So this is 3x. Measure of angle B is 4x plus 40. So this angle here is 4x plus 40. And it wants us to find all these different angle measures. So kind of using what went on with these others, opposite angles are going to be congruent. So if A is 3x, C must be 3x. And if B is 4x plus 40, D must be 4x plus 40. And altogether, these angles inside this quadrilateral need to add to 360 degrees. Our formula again, n minus 2 times 180 equals the number of degrees. For a quadrilateral, n is 4. 4 take away 2 is 2. 2 times 180 gives us 360. So all these need to add up to 360. Looking at combining like terms with the x's, we've got 3x, another 3x makes 6x. And over here we have another 4x and another 4x. 6x and 8x makes 14x. And number-wise, we have a 40 and a 40. That gives us an 80. And altogether, these have to equal to 360. Take away 80 from both sides. We have 14x's equals 280. And twice 14 is 28, so x is going to be 20. Now if x is 20, they want us to find the angle measures. A, measure angle A equals measure angle, A matches angle C equals 60 degrees, which is 3 times 20. And the measure of angle B is equal to the measure of angle D, which is equal to 4 times 20, which is 80, plus another 40, which is 120. So that's how we can do those angle measures for number 1. So all go, or for number 4 rather. This all kind of goes with number 4 here. Okay, so let's see what we got over here. Number 5, in parallelogram RSTV. So let me draw a parallelogram here. And let's call it RSTV. As long as you go in clockwise or counterclockwise order, it doesn't matter where you start, unless there's more information. It says diagonals RT, and VS intersect at Q. Now remember, one of the properties that we have of parallelograms is that their diagonals bisect each other. So it may not look it in this diagram, but those diagonals cut each other in half at Q. And it says RQ is 5x plus 1, and QT, which is this top half here, is 3x plus 15. And they want us to basically find the length of QT, which is this piece right here. So we have to think back. One of the properties of the diagonals of a parallelogram is that they bisect each other, which means that this QT segment is congruent to QR because Q is the midpoint. So we can say 3x plus 15 equals 5x plus 1. Then we would take, say, 15 away from both sides and take 5x away from both sides. So taking 5x away from 3x, we have minus 2x's. Taking 15 away from 1 gives us minus 14. Then we're going to divide both sides by negative 2. The two negatives cancel. We get x is equal to 7. It wants to find the length of QT. QT is 3x plus 15. So 3 times 7 plus 15 gives us 21 plus 15, which is 36. So QT equals 36. Okay, let's look at number 6. Explain why it's impossible for each figure to be a parallelogram. Well, if we look at number 6, they're talking about the sides here. Opposite sides in a parallelogram are congruent, and we can see that one of these opposite sides is a 10 and the other is 11. So 10 is not equal to 11. Opposite sides not congruent. That's what that opposite sides not congruent. Let's look at number 7. Now this deals with angles. The angles in a parallelogram, the opposite angles in a parallelogram are congruent. 50 and 55 are opposite angles, but they're not congruent to each other, and they're supposed to be. And so opposite angles not congruent is what causes this to not work. 130 does not equal 125, which is enough, but in addition, we also have 50 not equal to 55. So either one of these would be good enough to say it's not a parallelogram, but we happen to have both of these going on.